In this video, we are going to be continuing learning target 23. I can show the decimal expansion for rational numbers. This is part B. In the previous video, we learned how to convert repeating decimals to fractions when all the digits repeat. However, you will sometimes find rational numbers that are decimals that do not terminate. However, at a certain point, they begin to show repetition, which considers them still to be rational numbers. So when you do not have all the digits that repeat, the first thing you want to do, and again, this is the shortcut way. There is definitely a reason why this all works. However, due to timing, we are going to look at the shortcut way, and then in a future video, we'll learn exactly why this works. So we're still going to use that idea that nines in the denominator allow us to identify repetition. So you're going to identify how many digits are repeating. And in my first example here, 0.23 repeating, so 0.233333333, I see that I have one digit that repeats. So in my denominator, I'm going to have 19. Next, I want to identify how many digits are not repeating. So I have one digit not repeating, correct? That's the 2, not repeating. And in the denominator, I'm going to represent that as a 0. So I have one digit that repeats, one digit that does not. Then I'm going to take the number without the bar, without the decimal, so which would be 23, and I am going to subtract the non-repeating digits or digit. In this example, 2 is not repeating. So 23 minus 2 is 21. That becomes our numerator. And then, if I can simplify, I do so. So 21 over 9, well, 21, 2 plus 1 is 3, so this is divisible by 3. 90 we know is divisible by 3, so this would be 7 over 30. Okay. If we look at our next example here, identify how many digits are repeating, 0.9724724. I have 3 digits repeating. Okay, so in my denominator, I would have 3 nines. In number 2, how many digits are not repeating? I have 1 digit not repeating. So in my denominator, I would have my 3 nines for my repeating digits and my 1 0 for my non-repeating digit. And then I'm going to take that number 9724 and I'm going to subtract the non-repeating digit from that. And when I do that, I get 9,715. So that becomes my numerator, 9,715 divided by 9,990. Okay, and then I am going to see if I can divide that. So 9 plus 7 is 16. 17. 17 plus 5 is 22. That's not divisible by 3. So I wonder if there's any other... I'm not... Oh, well, they both end in a 5 and a 0, so I can at least divide by 5. So 9,715 divided by 9,990, so 9,715 divided by 5. And at this point, I am okay with you using a calculator to help you simplify, because these numbers can get quite large. So if you do need to grab a calculator to kind of help you reduce, that is okay. All right, so looking at our last 2 examples here, I have 3.286 repeating. So I'm going to just pull that 3 out in front, and I'm not even going to think about it. So in my denominator, I see I have 1 repeating digit, 2 that are not. And then if I have 286, I want to subtract 28. Okay, and that would give me 258. So I have 258 over 900. Those are both even, and 2 plus 8 is 10 plus 5 is 15, so it's divisible by 2 and 3, so that means that it's going to be divisible by 6, and which would give us 43 over 150, so my final answer would be 3 and 43 over 150. And then last, I see I have 2 digits repeating, so I'm going to put 2 9s in my denominator, 2 digits that are not, so 2 zeros. And then I'm going to do 9,872, and I'm going to subtract 98, which gives me 9,774. So my numerator would be 9,774. I'm going to use my calculator to help divide those. I know it's at least divisible by 2. And ultimately, if we worked through it, it would be divisible by 18, which leaves it to be 543 divided by 550. And that would be our answer.